The heart of the beast.
Yes, we've been doing all this business up now so that we can show you what a neutralization reaction is. We know the basic theory, what's an acid, what's a base.
Yep.
We know that a salt and a water will be produced.
Yes.
We know when an indicator will change color to tell you that it's done.
Yes, we do.
So now we're going to do the double replacements and show you what is up.
Show you what is up. So this is for your learning purposes. If you want to try and take some notes on this really light, you can. Right, but there's a lot here.
Yeah,
and there's a little bit more to go.
It shows you a lot on.
There is a lot of information, but it is showing us that there's going to be a double replacement reaction.
Mhm.
The plus ions, Na and H plus, are going to switch.
Yep.
So the plus of this is going to combine with the negative of this, and the plus on this side is going to combine with the negative on this side.
The cool thing about it is that the positive plus the negative, the Na plus the Cl, that's an ionic compound.
Yep.
And then the H plus the OH makes H2O.
Right. So we can always rewrite this as H2O. That's a given.
Mhm.
And notice I come up with a generic salt.
Yep.
This one just happens to be table salt.
Correct.
And water, which is what we taught a neutralization reaction would make, is an ionic solid salt with water.
Yep.
Period. And guess what? It is neutral.
Neutral because they have no ions, which to impart acidity or alkalinity.
And then here's a pictorial
Version of it.
method. Like, right, you can actually
Yep.
see the actual colored pieces where the
Right.
H from the HCl is going to
Mhm.
go over
Right.
to the white and red.
Right.
That's going to be my water. Bang, there it is over there.
Yeah, and then the Na,
The green and
Purple.
purple hook up.
they hook up, and then it's the NaCl. So there's another version of a neutralization reaction.
Right.
Let's do some on paper and see. Oh, wait, we got another video. I love it. This one here, it comes again. HCl, the acid comes in.
Right. And
Bumps
notice
into
it's not with
NaOH.
water, it's NaOH. It's actually hitting with
Swaps.
a base and making it. So there you go. There's another way to look at it. Hopefully one of those three ways worked for you in your brain.
Right. Neutralization. We're going to make a water molecule, at least one,
Yep.
maybe two or three, and a salt compound molecule.
So we did learn earlier on to say HBr starts with an H, so it's probably N.
Acid.
And
Hydrogen.
then NaOH
bromide.
ends in OH, so it's probably A.
If I had to name this and it's not on table K, I would call it hydrobromic acid.
You'd be very close.
Yeah, I think I'm right.
Oh, okay.
I don't know. Maybe I'm wrong. It's not on the chart. So
Right.
using the rules,
Right.
hydrobromic acid, hydrobromic acid, and sodium hydroxide.
There you go.
What do we
But I
make?
see an acid and a base, so I'm always going to take my pluses and my minuses. So I like to make the water first.
Yes.
Because it's easier that way. So boom, I just made my HOH, which is my water.
Yep.
What am I left over with? An Na and a Br.
Swap them up. See what's up. You
Done.
check your ion charges to make sure the charge is balanced.
Right, and in this case it does
Yeah.
fast, and we don't have to pick up a pen,
Right.
and then we're done.
One thing I would pick up a pen and do is
Is?
put AQ
Okay.
and liquid.
Sure, because water is liquid, NaBr is in water, so it's aqueous.
Yes.
Good. Okay, so next example,
This one.
that was a monoprotic,
This is a diprotic acid. When we say diprotic, we're just meaning that there's two
H's.
diprotic. So it has the potential to make two water molecules.
Yep.
So that's why we're going to have to do a little balancing when we're all done here.
Yeah, di and tri will need a little bit of balancing, but here, this is my kids really took on to this piece, so I'm going to do it for this. I'm going to label these up my
Love it.
pluses and my minuses,
Mhm.
okay? The pluses and my minuses work out good because I know the plus of the one molecule is going to hook up with the O to minus.
Yep.
Out in the other side. I said O, but I meant the minus, right? And I form HOH, which
Yep.
is water, H2O, really.
Yeah.
And so we can make that conversion. And then the plus of the other is going to hook up with the minus,
Mhm.
and I come up with this KSO4.
Right.
Okay. But here's the issue. I have H plus is a plus one, and I got two of them. So it's a plus two over here on sulfuric acid.
Oh, yeah. So he's got two H pluses over here.
So that's a plus two total. And I know SO4 is a polyatomic ion with a negative two. So if polyatomic ion negative two SO4 on the right hand side is a negative two, how many Ks do I need if it's a plus one? How many plus ones do I need to cancel out with a minus two?
Since we're replacing the K's and the H's,
Right. And K is also a plus one. I need two of them to cancel out with that minus two. So it becomes K2SO4. Now we need to do that before we can start balancing anything because we need to have stable compounds before we can balance. So that particular piece is going to be there. Notice when we talked about balancing before, I told you didn't bring the subscript over unless it was already on table E. So in SO4's case, that is on table E. So that's SO4, the 4 is coming over. I know it's a -2, so I get my +2. I need 2 +1s for my K. Now I can balance, right? I see 2 Ks on the right-hand side. How many Ks you see on the left? I put a 2 there. Oh, there it is.
Mm-hmm.
And then I see now I have 2 H's and 2 OH's, so now I need 2 R's.
Yeah.
Bam. Now we're balanced.
Moving on.
Moving on to a triprotic. 3 H's is a triprotic. Just in case you happen to see that, it's got 3 protons. Okay, so when I balance now, it's going to be, I got a -3 charge, and I got a +1 and a -1. All right, and hydrogen's got a +1. I might as well do that too while we're there. And then you can erase the bottom piece for me so we can animate.
Yep.
Here's my pluses and my minuses total. Monica put some numbers on there for us to help us. And I know that the positive ion on one side is going to hook up with the negative ion on the other side. So H and OH, put them together, I got HOH. Notice I'm not bringing a 3 over yet, because that's not how we do this. And then I got a plus and a minus hooking up. Wait, why are you going so fast?
I'm not.
I don't know. Go slow. Slow. It's not going slow. All right. Plus with a minus on the other side goes to LiPO4. And this is where we use the charges. I know PO4 has got a -3 charge right on table E. Li has got a +1 charge, so I must need 3 of those to cancel out. Now that I have, and then HOH is neutral, so now that everybody's neutral, I can start balancing. I put a 3 in there and a 3 in there, and we balanced. Good? Or we want to discuss how we balance that a little bit further?
No, it's
Pretty easy?
simple. I mean,
We
you
didn't count
just
them up
have to
underneath.
know your charge cancellation technique.
Yes.
Period. End
That's
of
the
story. Go watch the review on the balancing an equation for charge cancellation, because that's all we're doing.
That is really all we're doing. The HOH balances itself out easy. It's that salt that you got to use the crisscross to figure out exactly what the charges are. So the salt is aqueous, the water is liquid, and we is done with the whole video, I think.
You think?
I don't know. But I
Let's
think.
find out.
Okay. Oh, a little bit more to
See,
do.
I knew there was more.
All
So
right, so this one will be fast.
it's really easy. Remember,
Pluses and minuses.
Yep, so
Up
plus
we
on the
go.
H, minus on the BR. And then we'll take a plus and a minus. So I got HOH and I got KBR. HOH, KBR,
Gotta
done.
check
1 to 1 to
plus.
1.
Yep.
When you have monoprotic, it's already balanced. All right, next one. Na is a plus, OH is a minus, H is a plus, acetate is a minus. So Na hooks up with there, HOH. I always like to start with my HOH, because that's the easiest one. And then I got the C2 with the Na, with the acetate, and we are balanced because it was, again, monoprotic. So only in di and triprotics do we actually really have to do too much work. 3 is going to be real fast. K is my plus, OH is my minus, H3, triprotic, this one's going to be fun. So K with a PO4 and HOH, K with a PO4, HOH. I look at PO4 and I see that it's a -3 ion in table E. So how many +1s do I need to cancel out with a -3? I need 3 of them. 3 +1s gets me to a +3, and then that +3 cancels out with the -3. So I got to get the 3 in there. Now I can balance. I need 3 Ks on that side, and I need 3 OHs and 3 H's, and I'm done. Notice, I only got to take care of the OH piece, and wherever the OH is on the reactant side, it's starting to come into a pattern. So again, H is my plus, NO3 is my minus, Ca is my plus, OH2 is my minus. I'm going to hook up the H's and the OHs, and then hook up the other pieces to make a salt. Very good. And it's CaNO3, sir.
No. You're right.
There you go. And we're moving right along because we're about to run out of time. So I need 2 of those. And now we are just about balanced. And we are out. Good luck. Double replacements aren't that bad.
Bye.